Yeah, I'm Satya. Today we're going to see about Regulation 2023 Computer Network subject in 5th unit Digital Data Transmission. Okay, how the digital data is transmitted, that is we're going to see about here. So today we're going to see about digital data transmission. So how the digital data is converted into another digital format, digital to digital conversion. So this section explains how to convert the digital data into digital signals. Like it can be done in two ways. First one is line coding, second one is block coding. Okay, digital to digital data conversion is done by two ways. One is line coding, another one is block coding. For all communication, mostly we are using the line coding. Okay, for all communication, line coding is necessary, whereas block coding is optional. Line coding is necessary, block coding is optional. So line coding, see, it is the process for converting the digital data into digital signal. Okay, see how the digital data is converting into digital signal, that is said to be line coding. So the digital data is found in binary format. It is represented like a ones and zeros. See the diagram. Here centeries can transmit the digital data 101011 and etc. some 10. So it's a center is transmitting the digital data. This digital data is given to the encoder. The encoder is converting the ones and zeros into the digital signals. See, one is a positive signal, zero is a negative signal. Then one is a positive signal, zero is negative, and one is positive signal. And then this data is then given to the decoder. So decoder, here digital signals are transmitted into digital data format, then it's given to the receiver. Okay, sorry. Digital signal is denoted by a like a discrete signal. So which represent as a digital data. So the digital signal line coding is mainly divided into three formats: unipolar coding, polar coding, and bipolar coding. First one, unipolar coding. So unipolar encoding schemes use single voltage level to represent the data. Okay, unipolar encoding, it uses single voltage level, so only above the timeline. Okay, in this case, to represent binary, one is a high voltage. High voltage is transmitted. It's like a binary one, and zero is represented. Here, zero is no voltage is transmitted at the value 0. So it is also called as unipolar non-return to 0. So here is a there is a no rest conditions, 1 and 0, it's only one side, so it is a unipolar encoding. Next, polar encoding. So polar encoding, polar non-return to 0. So polar encoding, it's have the two types, return to 0, non-return to 0. So polar non-return to 0, it uses two different voltage level to represent the binary values. Generally, positive voltage represents 1 and negative voltage represents 0. So it is also non-return to 0 because there is no rest conditions. So non-return to 0 has the two variants, non-return to 0 L and non-return to 0 I. So non-return to 0 L changes voltage level at when different bit is encountered. Whereas non-return to zero I changes voltage when a 1 is encountered. When 1 is encountered, that is non-return to zero I. Next one, polar encoding. We see return to zero. So return to zero, like a problem with non-return to zero is that the receiver cannot conclude when a bit ended and when a next bit is started. In case when sender and receiver clocks are not synchronized in the non-return to zero. But return to zero, it's using a 3 voltage level. Positive voltage represent 1, negative voltage represents 0, and 0 voltage for none. Signals are changed during bits, not bits. Okay, signals are changed during the bits. Okay, we see unipolar, yeah, polar. Next one, bipolar. So bipolar encoding, it uses a 3 voltage levels, positive, negative and 0. 0 voltage represents a binary 0 and bit 1 is represented by altering positive and negative voltage. Okay, 1 is represented alternating positive and negative voltage. It is a bipolar encoding. Next one, block encoding. Okay, here we have seen the line encoding. In the line encoding, unipolar, polar, bipolar. Next, block encoding. So block encoding, it's a block encoding to ensure the accuracy of received data from redundant bits are used. For example, even parity, one parity bit is added to make the count of 1 in the frame even. This way the original number of bit is increased. So it is called as block coding. Thank you.